The next step, we actually build a neural network classifier. Let us see how it works using the scikit-learn package. We import scikit-learn. Oh, yes, actually, we only use the neural network classifier. So instead of import the entire package, we can do this from scikit-learn, and the submodule is called neural network. Let us import called MLP classifier. The name of this class would become clear later. That MLP stands for multi-layer perceptrons, so which indicates the connection between neural networks and the perceptrons we introduced last week. Okay, anyway, now we have the LMP classifier. Let us create such a classifier called MLP classifier. Let it to be a realization of the MLP classifier. And as in last week, we have introduced the models of scikit-learn is quite easy for us to use it, just like our experience of using the KNIME in the subject of introductory to data analytics. If you have experience in KNIME, remember that after we have prepared the data, we link a line from the data source to the model. The job we are doing now is analogous to linking the line from the data source to the model cleaner. So what we do is, if you do not have experience with KNIME, don't worry about that. The step we are going to do should be intuitive enough to explain itself. This is the instance of our multi-layer perceptron, that is neural network classifier. Let this classifier to be fitted to our data, and our data is called data X and data Y. X is the observable part of the data, and the Y represent the desirable predictions of the model. Now let us run the cell. It seems that we have trained a classifier with such attributes. Some of them we will explain later. But anyway, let us have a look at our classifier. We use this. Oh, okay. To be simple, now we have done to create a neural network and fit it to the data. So the next step, let us see the behavior of the neural network to check if it actually works on the data. MLPC, that is to predict for data X. That is called prediction. And we can compare the predictions with those desired values. How we do that is to print it out. Look, data X. Predicts print data Y. So this is a predicted value, this is a desired value, And we can also have a look at are those two sets of values the same or not. Predicts equal and equal, that means compared to arrays element-wise. Return true if these two elements are the same, false else. Data y. Let's run this cell and see what we look at. Okay, there's 150 values as the predictions, and followed by the desired values, and which again in turn is followed by the comparison. The true means the predicted value is the same as the desired value, and false means otherwise. It seems we do not have many false here. There is one false, that is misclassification, and well, another one. So the classifier performs pretty good, and that's done. So the core job is done in 3 lines of code, including 1 line to import the tool. In fact, the operational code has only 2 lines. Create a neural network classifier, which we now call it multi-layer perception classifier, and then feed the classifier to data. It's done. Well, actually, we need to do a proper job than this. You might think that, okay, in data analytics, generally we need to separate training data from test data. We cannot let the model to fit to this set of data and evaluate the performance of the model on the same set of data. That is unfair and is not practically useful, because it is quite possible for a model that fits the data and performs well, but when in application or in production, you give the model the data it hasn't seen in the training time, the model perform poorly, which we call it the model does not generalize. So let's do the proper data training process, like in for students who are familiar with KNIME, like in KNIME, generally we do some configuration of the data source. We set the data in 2 sets. One set used to train the model, and the other is used to evaluate the model's performance. Okay. In scikit-learn, we have similar functionality of dealing with the data source. What we do here is to from scikit-learn dot, it's called model selection, which explains itself because this set of tools are tools that helps you to determine which model is better than the others and select the best one to fit the project, and to separate data into 2 sets and evaluate how the model's performance obviously belongs to this set of function. Let us import. The name is also intuitive, called train test split. Okay, and to use the function, I know the usage, but you can always Google its usage by using the function's name and plus the scikit-learn. Almost certainly you will, Google will lead you to the appropriate documentation. Let's do the train x, test x, and the train y, and the test y. Notice that in Python, when a function returns multiple values, you can list those values without using any bracket or parentheses. Just delete those values separated by a comma before we call the function, which is linked by an equal symbol. So this function can return 4 sets of data: the training observation used in the test stage, and the desired sample used in training, and test Y. I remember previously I mentioned that this is a hypothetical variable. In practice, actually, we do not have such test Y. We actually, a more appropriate name for this variable should be validation Y. Those Y, we know it, but we pretend that we don't know it, and let the model to completely let the model has been completely fitted to training X and training Y, and then let the model see test X, which it hasn't seen in the training stage, and compare the output of the model on those test X with those test Y which we put away during the training stage. In this way, we can gauge how the model performs. And the input of the function is just the data. Actually, the function has few options. For example, allows you to determine the proportion at which we can split data to train and test. By default, I think the function will give about 1/4 of data to test and 3/4 to training. Okay, now instead of train on the entire data available to us, let model only see the training X and training Y. Let us run this cell. It gives us another model, and now let us evaluate the model according to its performance on the test set. Okay, that's test predictions test X. Okay, instead of printing the prediction and the desirable values out and comparing it manually, we can do the comparison test. Okay, the comparison itself a NumPy array, and we can take the sum of the NumPy array. If we summing the binary values of a NumPy array together, NumPy will treat the true value as 1s and the false value as 0s. So by summing the comparison, we actually counting the number of samples at which the prediction is correct. And let us divide this number by the total predictions it made. The total number in array is called the array size. But note that this will be an integer and this will be another integer. So in many programming languages, including Python, if you divide an integer by another integer, it will automatically round the result, which may not be what we need, because now we need something like a percentage. So we can change one of the integer into a float number. In this way, we will arrive accuracy between 0 and 1 of the classification. The larger the accuracy is, the better the model is. Let's run the cell to see what we get. Pretty good. we get accuracy of about 97.3%. So we have built a neural network classifier on the flower data.